Hello, everybody. I would like to go through a few topics. And the very first topic I would like to go through is using Excel to calculate the p-value for t-distribution. And this is very useful in Chapter 9, Chapter 10, and even in Chapter 13 and so on. And the second thing I would like to do is how to activate the data analysis add-in to our Excel session for Windows-based computer. And lastly, I would like to use what is known as the StatCrunch, which the Pearson Site offer. Uh, for many of you who have a Mac computer, this might be a very useful place to do the calculation. So let me first go to Excel and, uh, and let me try to find the p-value. So let's say at this time I know what is my statistical test value is, let's say, 3.1824, and I know my degrees of freedom. Let's say usually it's n minus 1, or in some cases would be different, but I know my degrees of freedom in this case is 3. And then I must decide about if I have one tail or two tail test. And let's say at this time I know I have a two tail test. So in order to find the p-value, I try to do it this way. And I go to writing down the formula. It's TDIST, and then it tells me what's x. X in this case is going to be 3.1824. Then degrees of freedom, I have a comma between that and my t-value. Degrees of freedom is going to be 3. And lastly, I have another comma and the number of tails. I have two tails here for my test. So I have closed the parenthesis, and by hitting the enter key, I would be able to come up with the p-value. In this case, if I enlarge it, you could see my p-value was 0.05 almost. Now, another example would be, let's say I have a stat test as a t-test again, and my stat test value for t is 1.87, and let's say my degrees of freedom is 6, and this time, let's say I have a one-tail test. So I'm going to do exactly the same thing as I did before. I need t this, and then I need to give the statistical test value, the t-value, it's 1.87, and then I need comma, then I need the degrees of freedom, which is 6, and lastly I have to say one tail or two tail. In this case I have one tail test, so it's 1.1 over there. By hitting the enter key, I would be able to come up with the corresponding p-value. Again, this time is 0.055. And now many calculators, scientific calculator could do that, but Excel is very efficient in this area as well. And the second thing I want to do is basically try to activate my data analysis add-in. Let me go to the data tab. And right now, my data analysis is not activated. And so as long as I am using window, I go to the office button, and over there I can see Excel option. I go to Excel option, and now I go to add-in on the left side. I try to open that, and there are the list of add-in, which they are very, very useful, are given. I'm just going to choose the first one, and I say go. And now it's going to give me dialog box, and I'm going to mark the first one again. It's Analyst Toolpack. Now, if I say OK, it's going to activate that. And I would notice that if I go back to data, and right now on my right-hand side on the top, I see the data analysis add-in. So if I click on that one, I'll have a lot of statistical method which I can use. And many of the statistical method I am using for DS34, you can find them here basically. You can see the t-test are there, and many, many others. If you have a window, this is how to activate it. As I recall it uh, for Mac user, I think you really have a difficult time to activate that. Only, I believe, maybe if you have Excel 2004, you might be able to activate the data analysis. But otherwise, I think the other option you have to go to the Pearson site and try to use the StatCrunch. Let me go to Pearson site and try to do that. If you go to the Pearson site by clicking on StatCrunch, you would be able to access that. Now, it takes a little bit time until I can open that. And now let's see, usually your textbook has the data, but usually I can download the data as well and access it differently. So let me now try to access my data. Now, the screen comes up and let me, on the left side, you can see that each chapter with appropriate data file is given. I could click on that and try to get the data this way. But I have another option, which is a better option. I already saved the data on as an Excel file, and I can get that. So let's say I'm trying to get the data for example for problem 10.12 of your textbook. I go and I try to retrieve that. Um, okay, I have saved that on my C drive. Let me go get that. And basically, I'm going to bring the data here. And let me enlarge the column size, column width. I can see clearly. Now, as you read the problem concerned with waiting time in two banks, Bank 1 and Bank 2, the data already is here. I have to decide about if this is independent case or dependent case. Clearly, this is an independent case, and therefore I go to a different statistical method. And over there, I know I'm interested in the t statistic because the independent case is based on t statistic. And then I go to sample. Uh, Basically, I'm not going to pair. I go to the sample independent one, and I have the data already. So I'm going to choose this. The screen comes up and asks me for basically the dialog box asks me for the data. Obviously, bank 1 is my first variable, and bank 2 is my second variable, and I'm pulling the variance. So I'm going to continue. And then it's asking me for what kind of statistical hypothesis I have. The mean difference is 0. Alternative, are they different? And therefore, that's a two-tail test. In case if I need a confidence interval, I could mark this and ask for confidence interval. And let me do not do that one and go to the next one. And where I want to store the data, I want to store the data in my data table right away on front of me. And basically, I'm going to ask for calculation of that. And so it's going to go through, and basically, it's going to give me the information. It says my HO is mean of bank first one, waiting time in the first bank is the same as waiting time in the second one. And under alternative, I have mu1 minus mu2. Mean of first one is different than the mean of the second one. I am pulling the variance, and eventually all the other information are given. And so here it's telling me that the degrees of freedom I have is 28. The statistical test is minus 4.134, and the p-value, and remember, this is a small p-value. This p-value actually, it is, if I have to write it down, is this one. I'm just gonna go decimal. This one is decimal point. So it is 0.00029 because the one we have it is in the scientific notation is 2.92 to the power multiplied by 10 to the power of minus 4. But if I really have to write that one down, it is 0.00029 and some change. And so obviously by using either t statistic, I could make a decision and compare that with T of table with 28 degrees of freedom and alpha over 2. Or if I can use a p-value, which is better way in this case because it's faster, I could compare that with alpha over alpha and make a decision. Now, let me try to do another problem. Let me try to load more data. And this one is problem 10.24. Uh, and that problem is dealing with before and after case. Clearly, this is a dependent case, and I have to make sure that I know I got to use a t distribution, but it's going to be paired one. And if I go to statistic, I have to specify that. Right away, I can see that. Now, the first column selecting, I think it's going to be B4, the first variable. And the second one is going to be after. And now I want to save the differences. I got to ask for next. And then I'm testing for mean of the first one is the same as the mean of second one. And then I'm going to ask mean of first one before is more than mean of the second one as my alternative. Again, I can ask for confidence interval here, or I could just leave it blank. And then I ask for next, and I'm going to store the output in the data table and calculate it. Again, there is a description of what's happening. It tells me this is how we define the difference before minus after, and the sample difference d bar in our case is 86.14. Standard error, it means standard deviation of the difference over square root of n is 46. Degrees of freedom is 6, and the corresponding statistical test is 1.84 and some change, and the p-value would be 0.057, and I have the difference column. So here, if I have to make a decision, obviously, again, I can compare my t-statistic with critical t-value from table, or easier, since I have a p-value, I could easily compare it with alpha and make a decision. So here, if I have access to table, I use this one. Otherwise, I just compare alpha with 0.005. If my alpha is 0.05 and my p-value 0.057, obviously my decision would be do not reject HO. Okay, I hope this would be helpful. Indeed, I could say that the StatCrunch, although it doesn't give you many statistical method, but it would be sufficient for most of the procedure we have.